Right. So as we said, in order to make aromatics react, we need to activate either the nucleophile or the electrophile. In this case, we're going to take a look at activating the electrophile to do our EAS mechanism. And so to do this, we're going to use a Lewis acid catalyst, right? So if you think about what a Lewis acid is, it's an electron pair acceptor. And by using a Lewis acid catalyst, we can make our benzene ring do all kinds of different reactions. So the first set of kind of reactions that we're going to learn is to add a halogen onto our benzene ring. So for example, if you wanted to add a bromine, you could add some Br2, same as the alkenes, and now you just add a Lewis acid catalyst. Generally, the one used here are iron tribromide or aluminum bromide. Right, either one of those catalysts. And what's going to happen there is then you'll just add a bromine into your benzene ring. If you wanted to add a chlorine, you would just use aluminum chloride. And then if you wanted to add fluorine or iodine, there are ways to do that as well, but we're just going to focus on the bromine and the chlorine. And so the way that this works is that the Lewis acid acts as a catalyst and makes our halogen more electrophilic. So for example, we have our Br2, and then we have our FeBr3. That's our Lewis acid catalyst, La-cat. And so what it's going to do is accept an electron pair. So this bromine has electron pairs right there, and it's going to attack our catalyst. To form this following complex. And so what we've done here by giving up some of the Br2's electrons is we've made it more positive, more electrophilic, right? We can see the full positive charge on that bromine. Right, we've made it more electrophilic. And you can think of this as being in equilibrium with a Br plus. Right, so you can see that we have a stronger, more electrophilic bromine. However, the mechanism is usually drawn from the complex. All right, so let's go ahead and take a look at the mechanism. So the first step in the mechanism is the formation of this complex. Once you have this complex formed, you can then have your aromatic system attack your complex. So we've got our benzene ring. We've got our more electrophilic bromine. Don't forget all of these charges and everything. And so your nucleophile is simply going to attack your electrophile, and then we're going to break off this bromine-bromine bond. So that's the first step. And U attacks E plus. And after that, what we're going to have is our sigma complex. And then from our sigma complex, we're going to deprotonate our sigma complex to regenerate our aromatic system. So make sure that you're deprotonating the correct proton. And in this case, since it's a catalyst, we need to regenerate our catalyst. So it's going to be our catalyst that does the deprotonation. So this iron bromine bond is going to pick up this proton, and then this carbon hydrogen bond is going to become a carbon-carbon pi bond. So here the sigma complex is deprotonated to reform our aromatic system. Note that our catalyst is regenerated, and then we have some HBr as well. And this the mechanism for the aluminum or for the chlorine is approximately the same. So I'm not going to bother drawing it, but it'll be on your work along.